All right, all right. Today we're going to learn about transformations of linear functions. And it is lesson 4.4, and you're going to be able to perform an operation, and the line's going to move up and down the graph. It's going to go left, right, up, down. Very, very intriguing stuff. In order to get to a certain point of understanding how our lines transform or translate, we're two different things. We have to first get some common vocabulary in terms of how we call our graphs. We'll call our graphs a family of graphs. From our family of graph, we have a mama graph or a parent graph, okay? The parent graph is really the simplest of the functions of the family. Now, when we're dealing with a parent function, it is called, I'll get this kind of cool here. This is called the identity function, okay? F of x equals x, or y equals mx. This transformation that I spoke of earlier, make a highlighter. Can I do a highlighter? The transformation that I spoke of earlier actually, oh boy, that just like cleared that up. I got a new computer, guys. This transformation will take your graph, your basic graph, and transform it. Might move it up here or down here or like this or like that. That's what we mean by transformation. It's gonna move it. Okay. There's one type of translation called a transformation called a translation. So transformations are the big guys. Translations are part of the big guys. Okay. A translation is essentially a transformation. Oh my gosh, I'm getting a little bit crazy here with my Cami. A translation is essentially a form of transformations where it's just sliding. We're sliding. Okay. When we slide, our direction doesn't necessarily change. And what I mean by that is what is normally up stays up. Okay, so if I'm looking at a vertical translation, if I'm sliding up, like so what goes up stays up. Look at my vertical translation right here. I start off with my parent graph. That's the mama graph right there. Okay, that's the parent graph. When I go up a certain amount of units, that means it's a positive value. So I'm going to move it up. In order for it to go up, it's going to be a positive value. It's going to move up a certain amount of units. If it's going to go down the y-axis, if it's going to go down the y-axis, this is going to be less than 0. It means that whatever I'm adding on to my f of x or my g of x or my k of x, whatever my m of x, whatever it happens to be, whatever my function is, if I'm going to subtract it, it's going to go down the axis. If I'm going to add it, it's going to go up the axis. Okay? So here, if you'll notice here, here's my parent graph here. When this is going up the axis, that's a positive value. When it's going down the axis, it's below 0, or a negative value that's below the axis right there, okay? Plus a negative. And if you think about it, if that's my y-intercept, isn't it? My y-intercept is in a negative spot or a positive spot, so that makes sense. When I am going to give an example, like in real life, but in graphical, algebra life, g of x equals x minus 2. You can put your values in, -2, 0, and 1, and you can plot your points. You'll notice I'm at my f of x, or my g of x, which is just right here, this graph right there. But if I'm going to drop it down 2 units, 1, 2, the entire graph drops down 2 units, and my intercept is also 2 units over, okay? So I call it a translation of 2 units down. Since my k, this is the k, plus or minus k, that is my constant. That drops down. Yeah, did I talk about what the k happens to be? Yeah, k is just what you're adding on to. K is your constant. So that is my constant. Now take a look at this graph here. G of x is y equals, g of x equals x minus 1. What are you going to do with that particular graph? You're going to take it, and because it's less than 0, it's dropping down. It's going to be less than 0. It's going to go below the x-axis, drop down below. It's going to be vertically moving down on that y-axis. So it is going to be doing something down here. This is -2 here. Sorry, my new computer's making a weird noise. This would be the -1, so it's going to go like that. Okay? Yay! All right. Did I get that already? Horizontal translations will go from left to right. Horizontal translations look a little bit different. They look a little bit different. The horizontal translations, let's change my color. I kind of like it pink. Okay. Why didn't it save that? Did not hit save? I hit save. I'm hit save. Sorry about that. Okay, so horizontal translations are going to go this direction. Oh my God, I kill myself. All right, there you go. This direction. Now, if h is bigger than 0, if my h is bigger than 0, then it's going to go to the right. If h is less than 0, it's going to go to the left. It kind of makes sense because the graph looks like this now. So it's not f of x. It's not f of x equals x minus 2 or x plus 2. It's in the parentheses. And there's a little bit of a slight difference in that, okay? So when I'm doing that, I have to move to the left or to the right. So if it's a plus, if it's greater than 0, it's going to the right. If it's less than 0, it's going to the left. So let's take a look at this graph here. If I have x plus 5, when I put that in there, okay, put in my values of -2, 0, and 1, here are my resulting values here. Okay, so I got some resulting values there for my g of x. When I put that in there, I put in -2 plus 5, out comes 3. So I put in -2, and I get 3. 1, hang on, where's my -2 at? Hang on, let me press a pause for a second. I can't, I didn't know where my thing is at. Hang on. Sorry about that. I didn't see that very well. If I put in, -2, I didn't put in +3. I put -2 here, not -3, up here and over here. That's what that makes sense. Okay, so if I put in 0, out comes 5, and I put in 1, out comes 6. So that is that graph right there. So when I'm doing this, when I'm graphing it, because that is bigger, if I take a look at here, because this is this, and now here's where it gets confusing. This is x minus h. So to understand that the actual graph, the parent graph for this particular case, when I'm doing not the parent graph, when I'm dealing with this graph here for my horizontal translations, it's x minus h. Okay, it's x minus h. Is going to be a little bit confusing. It's a little bit misleading because this is x minus h, but if you look at it, really, it's x. You have to treat it as a negative coming up this direction. So it just goes the exact opposite of what you think it's going to be. So that's just one way to remember it. If I'm looking at this thing right here, if I think of it there, x plus 5, that means to think of just the opposite. So when I'm looking at horizontal translation, it's just the opposite. This is x plus 5, it's going to go to the left. If it's x minus 5, it's going to go to the right. So looking at x plus 12 for my new function here, it's going to go 12 units to the left. Okay, because you think, oh no, it should go to the right. It's going to go to the left. It's different than the vertical translations. Look at this particular translation right here. This is a whole hot mess going on here. Okay, whole hot mess going on here. So not only do I have this guy right here, but I'm going to take that graph right there, which is going to go to the right, because again, it's the opposite. Now it's going to go up 3 units, right? 3 units alone is different things. So I'm taking a look at this. Let's fill in these blanks right here. Hang on 1 second. Okay, now I have a new text tool I have to type in here, because this is a little bit challenging. Oh gosh, hang on. Don't go anywhere. Equals 6. Okay. So I'm looking at this. So when I look at this graph here, look at this graph that we're looking at right now. G of x equals x minus 6 plus 3. Describe this translation as it relates to the graph of the parent function. Here's my parent function, f of x equals x. Now, if I'm going to use it in terms of how they have it set up like this, I know that g of x now equals my f of x, which is my function over there, which is x minus 6, right? And let me hang on a second. This should be, let me grab this guy. My selection tool. This guy should be, this is h equals 6. There it is. Yep, h equals 6. And, or h equals 6, but k is my constant. K is the number outside of the parentheses. K is going to equal 3. Okay, because k equals 3. So my h is a 6, the k is, it says x minus h essentially plus k. That's what it's just, they just don't worry about the f and g swapping out. They're just saying this is the function. Because of that, this is what this is going to end up being. Okay, so now I have g equals, if I were to say this here, I could say now that I have, hang on, let me just type this up really quick. Okay, so it's just like saying I have, here's my new function. Instead of that, I'm going to have my function f of x minus 6. They're just substituting that in there. It's not changing anything, really. I understand the concept that now the function is now in there. So it was a function before the g of x. They're saying, how is it going to relate to the parent function? So now you're relating to the parent function. We word it a little bit differently. So I take my parent function was f of x. This is my f of x is like my parent function. Here's my parent function here. What's happening to it? Well, I'm getting translated 6 units to the right. Again, it's like the opposite, right? If I'm x minus 6, I'm going to the right. If it's x plus 6, I'm going to the left. So that parent function is being translated. However, now I'm dealing with the k, that's the number outside the parentheses. That k is plus 3. So I'm going to be going 3 units up. What's up? What's up? There you go. Okay, 3 units up. Okay. So that's what's happening to the in relation to the parent function. I'm comparing this guy here to my parent function. So I put my parent function in there. I'm moving 6 units to the right and 3 units up. So that's exactly what that means there. Okay. What's next? I can't move it. Okay, here we go. All right, so let's take a look at this problem right here. Go ahead and read that problem. Press pause, read the problem. Or not. There we go. Oh my gosh. Okay, I kind of wrote this part over here because it makes a little bit better sense to me. We know that our parent function, or the original function in the terms of this particular problem, is f of t equals 12 times t, because they told us, A, that it was, because that's how the price could be modeled of the tickets. So it's 12 times t. However, with that extra $4 per order on there, it's a service charge, I'm guessing, a service fee, that's added onto the function. If I look at the new one, this is the f of t, which is like the original $12 a ticket. But then I add this on for the game tickets because of the service price. This is how they model the service price in their f of t plus the k. Well, my k is 4. So if I substitute in for the new total cost that we have for going to the game, it's the function, my original function, my parent function, plus the $4 extra. So this is g of t. So in terms of business, we have our one function, which is the function that gives us the price as is, but then it's another function, and we have our service fee added on to that. What does that mean in terms of the mathematics? My constant k, and I spell it k because I think it's German, honestly, that's f of t plus 4. So constant k is added to f of t after that. So really what's happening to your graph is going 4 units up. So if I look at the graph of this, there's my normal graph here. This is my f of t graph, and I'm going 4 units up. Yes? And don't forget, it's going to be a little bit steeper because it's 12 times plus that 4 times that 12 times t plus. I'm moving it 4 units up from the 0 here. Hang on. From my 0, 0 here up to my 0, 4 there. Okay? So go ahead and I want you to actually graph. Actually, I won't graph it. Okay. Just describe this translation here, kind of like we described it over here. So I want you to do the check kind of like that. Go ahead and do that now. Ha! Psych. That is my phrase that pays. Psych. I'm not putting that answer up there. You have to do that answer there. If your answer is not written down on here, you're not going to get the full credit because you have to listen to what I'm saying too. It's not just enough just to copy what I write down. You have to listen to what I'm saying too. That is the extra credit. If you want to get 4 points plus extra, you have to do that. If you want to just get 4 points, you have to have writing down here. You have to do this check on your own. Okay, and that's it.